Hi guys, what's up? Today we're going to talk about Km and Vmax. So what's Km? Let me use another pane. What's Km and what's Vmax, right? So these are terms you will see in enzyme kinetics, or you can see in pharmacology also. So what is Km and what is Vmax? Suppose, before getting into this concept of Km and Vmax, let's get into the concept of affinity. So what's affinity? Suppose here is an enzyme, right? And here is your drug A. Now this drug A readily and rapidly goes and binds with the enzyme, right? And here is another drug B. And this drug B, there is one molecule of drug, suppose, and this one molecule of the drug B cannot go in here. So if you give another drug B, it also cannot go. And again, you add another third molecule of the drug, again it cannot go there. Now you keep on adding the number of the drug molecules. When it becomes 4, now it becomes able to make it into the enzyme, right? So only one drug molecule of A could go into the enzyme and bind there, but 4 of the molecules of the drug B were needed for the drug B, one molecule per drug, to get into the enzyme or to bind with the enzyme. So you see here, the affinity of the drug A seems to be more. Affinity of A seems to be more, and affinity of drug B is less. So what is affinity? Affinity is nothing but it's just the capability of or the ability of the drug to bind with the enzyme. How readily or how rapidly or how easily the drug binds with the enzyme. That's the affinity of the enzyme. Sorry, affinity of the drug. So affinity is in fact the property of the drug, right? So with this concept, let's get into the terms Vmax and Km. Suppose you have enzyme 1, 2, 3, and 4. You have 4 same kind of enzymes, and you have another drug, right? Suppose you have a drug A. You have a drug A. Now you give this drug. Now one drug cannot bind with enzyme E. Now you again add another drug. It also doesn't bind with the enzyme. And again, you add another drug. It also cannot bind. And again, when the drug molecules become 4 in total, then only one drug can bind with the enzyme, suppose. Now again, you add more amount of the drug. And again, when the concentration of the drug becomes A, only 2 drugs bind to the enzyme. And again, you keep on adding the drug. And again, out of this, for 12 drugs, only 3 drugs are able to combine with this enzyme. Now again, we added 4 drugs, and out of this total 16 drugs, 4 drugs became able to bind with these enzymes. Right? So now you see here, these drugs in presence of these enzymes are metabolite, and total metabolites formed are of 4 different drugs, right? So you see here this enzyme system, which consists of 4 same kind of enzymes. These enzymes are working at their max speed. This enzyme system is working at its best. So it could happen only 1 drug per unit time, or only 2 drugs per unit time, but it's 4 drugs per unit time, right? So the enzymes, all these enzymes are working at their max speed. So this max speed is called Vmax. So what is Bmax? Bmax is the maximum speed or maximum rate at which the enzymes or at which the reaction is occurring at the presence of available enzymes. So Bmax is the maximum rate of the reaction in presence of the available amount of the enzyme. Right. So this is Bmax. Now let's talk about what is Km. So Bmax is basically the property of the enzyme system. Right, now let's talk about the Km. So what is Km? So the maximum capacity or Bmax of the enzyme system is 4, may it be milligram or 4 drugs, whatever. 4 milligram or 4 drugs per unit time. Now, suppose you you gave only 8 of the drugs. If there are only 8 of the drugs, then 4 drugs could add only 1 drug in here, and another 4 drugs could add only another drug in here. Now you see, the enzyme still has capacity that's not being used, right? Only half of the enzyme's capacity is being used. So if here were 18 drugs, then 4 of the enzymes were occupied, or 4 of the enzymes were working, right? But now, when there's only 8 drugs, only 2 of the enzymes are occupied, and now, if the max speed was 4 drugs or 4 milligram per minute, now half of the enzymes are being consumed, and only now the speed becomes only 2 drugs per minute. So now you say it is now the Bmax. The meaning of Bmax was actually 4 drugs or milligram per minute, but all the enzymes are not utilized here. So now the velocity of the enzyme, the reaction is only 2 milligram per minute. So at this concentration, the reaction is occurring at half of the maximum speed. So what is Km? Km is the concentration of the substrate or the drug at which the reaction's velocity is half of the maximum. Or in other words, we can define Km as the concentration of the substrate that's required for the velocity of the reaction to reach half of the maximum speed. That's called Km. Now that we've talked about the Km and the Vmax, now let's talk about what can be the difference or effect of non-competitive inhibitor and the competitive inhibitors in the Km and Vmax value. So before getting into that, let's talk about what is non-competitive inhibitor and the competitive inhibitor. Suppose in this reaction, if I add a drug X. Now if I add a drug X, if a drug X gets into this enzyme, now it seems like it took 4 different drugs to get into the one enzyme, right? But it took only 1 drug to get into the enzyme. So it seems like this drug has more affinity than this drug, right? So this drug has more affinity. The affinity is actually the property of the drug. So this drug seems to be having more affinity than this drug. But again, even if the drug sits in this enzyme, if you add more drugs here, the drug A can again replace this X. Now you see, this X has come here as the competitor of the drug A. So the competitor X has been again replaced with increased dose of A. So even if the X is the competitor of the drug A, is the competitor that can be beaten, or when the concentration of the drug A is increased, the X is again replaced, right? So the X is replaceable if we increase the concentration of drug A, and this type of competitor is what we call competitive suppose if there is one drug Y and the drug has very great or high affinity, so it goes into the enzyme system even if one drug molecule is present there. And now, even if you add more amount of A, the A cannot replace this Y, because it's like the Y has already and irreversibly used that enzyme. So Y cannot be replaced even if you increase the concentration of A to any amount or any extent. So Y is a non-competitive inhibitor because it cannot compete with this Y. But X was our competitive inhibitor because by competing with the X, by increasing the dose of the X could have been replaced by A again. So X is the competitive inhibitor. So if we add 4A, then again the X can be replaced by A. So now we know what is competitive inhibitor, and we know what is non-competitive inhibitor, right? So these are the two things. Now, if we add a competitive inhibitor like X, which has more affinity, then X goes in here, binds with the enzyme E. But what happens if we add competitive inhibitor to the value of Km and Vmax? If we add competitive inhibitor like X, then it replaces the A, then again another X, it replaces the A, and again another X, it replaces the A, and again another X, it combines with the enzyme. Now you see, in place of all the A, it has been replaced by the X, right? Now, suppose the first Km value was 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Now, when the X replaces all the A, now what we can do is we add more A's, right? 4A equals 1A, another 4A equals 1A, another 4A equals 1A, and another 4A equals 1A. Now you see here, initial concentration was 8. Now the concentration of the substrate, now the concentration of the substrate, we added, now see, here are X and here are X, right? So now you see we added 8 again. See, we added 8 again, right? So when we added 8, now the two X's are replaced by A. Now again, it can again work at half of the max speed. It can work at half of the max speed. So Km is increased, and now the concentration increases. It becomes, the reaction has half of the max speed, becomes 60, right? 60. So initially Km was 8. Now the Km after competitive inhibitor has been added, now it becomes 60. Now when the concentration of the substrate has to be increased, it seems like the affinity of the drug A has been decreased, right? Affinity decreased. So what happens if we add competitive inhibitor? If we add competitive inhibitor, what happens is the Km value goes in increasing. That means when we add competitive inhibitor, that decreases the affinity or that increases the Km of the drug. So this is what happens to the Km when we add competitive inhibitor. Now what happens if we, what happens to the Vmax? You know, when we add competitive inhibitor, it replaces the A, right? But if we keep on adding more A's, till all the X are replaced by A, then what happens is we can again get the Vmax, which was 4 drug or 4 milligram per minute. So the Vmax is actually the property of the enzyme. So Vmax does not change. What changes, Km can be changed. The concentration at which the reaction occurs at half of the maximum speed, that can change. That can we may have to increase the dose of the drug A, but if we increase the drug to so much enough amount, the velocity of the maximum speed of the reaction can be attained, and the reaction speed can be the same. So Bmax remains constant. Bmax remains constant, but Km increases, right? This is a gist we wanted to talk about. Now, what happens when non-competitive inhibitor is added? The non-competitive inhibitor, like Y. If we add Y, what happens is the Y gets into here and it completely inactivates the enzyme. So it completely inactivates the enzyme. So when the enzyme gets completely inactivated, the whole enzyme system's capacity decreases, right? Now, the property of the enzyme system is decreasing or changing. So now what happens is, even if you add more amount of now A's, the A cannot replace the Y, because this has permanently decreased or inactivated the enzyme. So no matter how much A you add, these A are going to remain only in these 2 remaining enzymes. So when you add non-competitive inhibitor, Vmax, the whole capacity of the enzyme decreases, but it does not change the property of the drug A. It does not change the affinity of the drug A, because this whole system is not working to its max speed, not because of the decreased affinity of the drug, but because of decreased capacity or the decreased velocity of the reaction, or the decreased ability of the whole enzyme system to work, because 2 of the enzymes has already been permanently inactivated. So the Km remains constant, or the affinity remains constant, right? So our gist is competitive inhibitor. If we add competitive inhibitor, what happens is Km increases. That means affinity decreases. And what happens to the Bmax? Bmax remains constant. And what happens to the non-competitive inhibitor? The non-competitive inhibitor, if we add that, it actually decreases the Bmax, but the Km remains constant, or affinity does not change, right? So this is a gist we wanted to talk in this video, right? So this much for this video. We'll talk about next topic in next video. Thank you.